Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Bizadi and I will talk about additional theory. First, Reynolds number. Reynolds number is a dimensionless quantity that determines if the fluid flow is laminar or turbulent. The magnitude of the frictional effect can be calculated for laminar flow which occurs for Reynolds number less than approximately 2000. And the equation for Reynolds number is as below. Second is the Peirce law equation. Peirce law states that the flow of a liquid depends on the following variables such as length of a tube, radius of tube, pressure gradient, and the viscosity of the fluid in accordance with their relationship. The Peirce law formula is given by as below. Okay, lastly is the Darcy equation. Darcy equation is the frictional effect is indicated by the friction factor and depends upon Reynolds number and the turbulent flow. The ratio of pipe surface roughness to pipe diameter. The friction factor is related directly to the loss of total head along the pipe. For constant pipe diameter and flow velocity, the head loss is most easily observed by the reduction of indicate level in piezometric tubes connected to static pressure tapping drill in the pipe bore.
Assalamualaikum and hi, my name is Shazwan. So we start with introduction. For the introduction of the experiment, the friction resistance to which fluid is subjected as it flows along a pipe results in a continuous loss of energy. So in this experiment, we actually try to study the friction resistance upon a flow during an pipe. The different levels between piezometer represent the total heat loss in the length of pipe. Osborne Reynolds recorded a number of experiments to determine the law of resistance in the pipe by introducing a filament of dye into a flow of water along a glass pipe. He shows the extent of two different types of motions. At low velocity, the filament appeared as a straight line in which passed down the whole length of the tube, indicating laminar flow. So we're moving on to the additional theory. Assalamualaikum and hi, my name is Shazwan. So we're moving on to the observation. So during the experiment, there are water inlet from the bench resulting in the increase of water in the both sides. The experiment, the value of H1 has direct influence to the rate of water dispense because during the experiment we have a beaker that collecting the water, and for a certain amount we will need to collect the time recorded. And then while adjusting the valve at the H1 based on the data, the value of H2 will affect it directly. Then the measuring cylinder was empty before the experiment started. After a few seconds, the measuring cylinder was loaded with water and the time was recorded. And finally, the temperature of the water indicate the same value during the whole experiment. So that's all from me. We're moving on to the next.
Okay, this is the procedure of the project. First, set the apparatus on the bench and level so that manometer stand vertically. Second, fully open bench, supply valve and adjust until there is a steady flow. Third, open partly the needle valve to allow water through the system. Fourth, remove the trapped air by manipulating the flexible connecting pipe. 5. Close the needle valve after the level in the two lines in the manometer give the same value. 6. Adjust the height of the water level by allowing air escape through the air valve at the top or maybe depressed by pumping air through the valve. 7. Open the needle valve fully to obtain a differential head at least 400 mm. 8. Collect the discharge rate by measuring the volume of 300 ml in the measuring cylinder and record the time. 9. Let the reading be stable for a while before recording H1 and H2. Then take a few readings and record the mean value. 10. close the needle valve so that the H1 valve is reduced about 20 mm, and then repeat the step onward. Lastly, record the water temperature at a frequently interval.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashadi bin Zanzari. Today I would like to talk about the result. This is the table that have the data and the calculated data and the recorded data. So we have to find the slope of linear portion for the graph 1, which is we have to find the y2 minus y1 over x2 minus x1. And we got the slope of the graph, which is 1.25. Then for the discussion part in question, discuss the result of the graph. Graph 1 shown that the value of the hydraulic gradient are decreasing linearly with the value of velocity. Graph 2 that shown when log f is constant until value of log re, which is 2.345 until 0.7705. The value of Re is decreased through the value of H1 is decreased. The relationship between log f and log Re is inversely proportional as log f increase. Graph 3 that shown the value of log I and log Re is decreased and affect the line of the graph. Next, rewrite the equation 9 in the form of kinematic viscosity. I equal to 32 RV divided by GD power of 2. And we obtain the new kinematic viscosity equation, which is V equal to Ig d power of 2 over 32R. For the question C, insert the slope value I over V to get the theoretical value of kinematic viscosity, which is V. After we obtain the value of slope, which is 1.25, we jot down the all value and we got the value theoretical of kinematic viscosity. V equal to 3.4488 exponent negative 6 meter per second. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Hakim bin Fazila. My contact number is BD20033. So today I'm going to present about discussion. So for D, compare and discuss the result of theoretical and experimental value of kinematic viscosity. So from the experiment, there are slightly some difference in the value of the experimental value. The value of the kinematic viscosity for the theoretical that we got is 3.4488 multiply 10 in the power of negative 6 meter per second. So the difference occur when there are air bubbles being trapped in the manometer tube. This will affect the data of H1 and H2 that we get will be inaccurate. So there also might be some parallax error happen during the reading the data measurement. This error will lead to the data that we get from the experimental value different from the theoretical value. So for example, for the parallax error, there might be when the ice is not parallel to the data measurement, so there might be some error. Next, for E, explain the effect of friction due to the flow change Reynolds number from laminar to transition. As we know, the formula of friction is if F equal to Re over 64. When the laminar flow change into the transition flow, the friction and Reynolds number will increase. The velocity of the flow will also increase as the flow will become more turbulent. When gaseous liquid move along the pipe, friction between the pipe wall and the liquid can cause pressure, head loss, and lead to a greater loss. So last, for F, find the critical point where the flow change from laminar to transition flow. So from the graph, the critical point that we get is at point 0.129 for x and y is 0.0573. So the velocity started to increase drastically. This happened when laminar flow started to change into the transition flow.
For recommendation, for the experiment that have been done, there are some errors occur during the experiment that will affect the results. There are some steps that should be taken to avoid errors. First, ensure that the valve is tight enough to prevent leakage during the flow. Second, every air bubble in the tube need to remove. Third, the reading should be taken repeatedly to minimize the errors. Fourth, the location of eye should be perpendicular to the scale to avoid parallax error. And lastly, water level should not be exceed maximum level in tube.